Hello everyone, my name is William Luzi. I am a student from La Perante University of Technology, and today we will discuss about systematic material selection for a wind turbine. This is a requirement for a discipline selection criteria of materials. A wind turbine is classified as a green source of energy and also a renewable energy that we can utilize the force that we have in a wind and turn it into electric energy. So the importance of selection materials for that to get efficient equipment is an important issue that we will discuss today. The part selected to be discussed on this study today is the wind turbine blade. So, as we can see here in this picture, is a really demand piece of the equipment that has aerodynamic shapes, complex shapes, and also we are talking about here a length of the blades nowadays is about 80 meters. So it's really important to select a good materials to get efficiency in this sense. So for the selection of materials, we must know some functions, the requirements that we will need to be able to make the selection, the best selection of material as possible. So for the wind turbine blade, I highlighted some points that we will discuss as a requirement functions for our material selection. High strength, one of the requirements is the high strength to withstand the torsional moments and moments on the blade rotor due to the self-weight. This is one requirement. Another requirement that the blade must fulfill is the lightweight. Another one, corrosion resistance, impact resistance, fatigue resistance. Another issue that must be discussed is not only the material properties, but it's how and if it's possible to based on the material it was selected, is it possible to get manufactured the blade? And also material must fulfill the low cost, material low costs. The blades, here we have a picture about the wind turbine. Here we have a rotor with 3 blades. These blades will be subjected loads as aerodynamic loads, and also the gravity loads. It means the self weight of the blade will act as a cantilever beam here, so we will get deflection here. So the material that we will select here, combined with the shape, must withstand the weight and it doesn't get so much deflection. So strength is also an important issue here. I selected index material to optimize the weight correlating Young modulus and density. So this formula here is the correlation of Young modulus, elastic modulus of the material, and also the density. This is to get the light as possible material that we can. I made one table selecting here 6 different materials. So we have the elasticity modulus of these materials and also the density. The highest index that we can have here will be the material that will get us the less weight as possible using this index here. So the material that we have that gave us the highest index, it was the balsa wood, utilizing this index here. Another important issue, another request that we must discuss also for the material is the corrosion impact. But this issue here, as we can see, it doesn't matter which material we will have. Of course, material must have good corrosion resistant, impact resistant off, but we can use like painting, like covers as a polyurethane that could improve the material capacity of corrosion and impact. So we not are stuck on the corrosion and impact resistance of the shell, because we can use some kind of covers to improve these characteristics of the material. Here I select this kind of graphic, this kind of map that can show us different kind of materials, and here we are correlating strength against cost. So to fulfill the requirements for moments, we need a strength material, but we also need a low cost material. So I select this area here. So in the right side we have expensive materials, in the left side we have cheap materials, and actually in the vertical axis we have the strength. So how as high as the material is, stronger it is. And how low it is located, weak is the material. So we want strong materials, but we also need low cost materials. So I highlighted this area here, and in this selection we could say that metal alloys is a good material for the blade, and also one part of the composite materials that comprehends this big circle here. One part of the composite we could also use as a selection of material for the blade, and also ceramics let's say that could be one possible material on this sense. But of course, ceramic is really difficult to get the complex shape of the blade as we can. So we could say here, take a look on this graphic, that metal alloys and some part of the composite materials could be a good selection. Another graphic, another material map that I'm using here is related to Young modulus and density. So another functional requirements that we have is material must be rigid enough, stiff enough to help in that moment resistance. So in the same way analysis we did before, we would like to have high stiffness, but also low weight of the material. So in this sense, we can see here composite materials and also wood could fulfill these requirements of weight and stiff. Based on all that, the discussions and that maps that I'm did before, I made this 4-field analysis graph that correlates here strength of the materials, stiffness of the materials, cost, and also the weight of the materials. So I put that 6 materials here and the correlation properties of that materials to see how will be the material that fulfill better the requirement that I established in the beginning, that requirement functions. So here, if we think about Young modulus stiffnesses and cost, we would like to have high stiffness and low costs. So the materials that I am interested is highlighted in red here. So GFRP is glass fiber reinforcement polymer, so compound material, and also steel could be the materials for this selection, for this purpose. Talk about less weight and also stiffness, stiff enough, as we did before, making that index that regards to the elastic modulus and density of the material. So in that previews, we get that balsa wood has really the biggest index as possible. So the materials highlighted here are the materials that are interested when we are talking about the weight, the reducing in weight of the material. So the materials are highlighted here in red. When density, correlating density and strength, materials that I'm interested is highlighted here in red. So we have polymer, composite materials here, and also aluminium. So no alloy material, no ferritic material here, aluminium. So the material that appears most constantly here, and I could say that I will select to make the blade, it will be the composite material, this glass fiber reinforced polymer. So as we can see, they are in all highlighted fields here. So I would say that in this analysis we could go forward with the construction of the blade using composite material. And also I would like to just talk about also another requirement. It was the manufacturability of the blade. The blade is made of complex shape during the aerodynamic shapes. So I would say also that composite material fulfill the requirements for that, because it's really easy to deal with, and could also fulfill that requirement for manufacturability. Okay, this is all for today, and thank you very much all to listen this presentation. See you, bye.